All right, so the agenda today, I think I got two parts of exercises for us to work through. The first part will be just about some eclipse doing 2D arrays. I got two exercises for us. We should be able to go through both of them. They are not very difficult, but I think at least you can see the very basic manipulation for the 2D arrays using nested loop and do some very simple arithmetic. I will see maybe later weeks we can add some more challenging exercises. But I think this week, together with last week, that should give you the basics about 2D array. Make sure you review them. So later on, when we touch upon the implemented strategy adjacency matrix for graph, you will be able to actually do the basic operation, right? We are really preparing you for that. And the second part will be just do some bingo notation. I think I just chose some very basic ones, sounds not very difficult, but some intermediate one as well. We'll see how many we can go through. And then for next week's lecture, we'll do some like a more advanced one, like a dynamic array. I think we can save that for the proper lecture. Okay, but today, make it relax. So maximum, I'll go until 5:20. But if we can finish earlier, we can finish earlier. There could be some exercises I can assign to you to actually do and then give you the solution. Okay, that can work too. All right, so let's now, first of all, I'll show you where the materials are. If you go to the lecture site, you will see that under the study materials, you can see under tutorials right here, right? So now we are in week number 2. So I will try to maybe put up some formal instruction for week number 1 as well, just for your record. So week number 1 last week, I just put it as an e-class announcement. I can convert it into PDF very easily. I can do that too. So you can also save all the materials, on your computer. So for this week, we're gonna do 2D array and also some big O exercises. So recording, I'll post it later, maybe over the weekend. And this one here is the instructions. Okay, I'll keep this one handy and then we'll look at that, right? So you can download it and look at what the problems are. And then we have, okay, let's go back. And then we have the notes on my iPad. I'm gonna also post it together with the recording. And this is the starter project you wanna do. I'll try to make it very similar to the format you will have to tackle the problem, during the actual test, after the reading week. So we're gonna have JUnit test, and also there will be some code you have to develop from scratch, which I'll show to you also today. Yeah.
I thought it was a written test. Are we gonna enter a programming test?
Yeah. So you can think about we got 2 tests right on the calendar. So each test is gonna be divided into 2 parts. The one part will be programming, the other part will be written. That's what I said in the syllabus section. Maybe you missed that part. Yeah, that's okay. So I'm just telling you, right? That's exactly what I said in the syllabus section. But I will let you know exactly what you can expect, before the actual test. But just remember, there are 2 parts for 2 of your midterms. There will be written parts, which will be done on E-class, and also the programming part. That's going to be done on Eclipse. Okay. All right. So let me show you how you can download the projects and also import the project into Eclipse. That's also some step you have to be very familiar with in the actual test. So let's download it. Let's click on that. And then you're going to download it somewhere. Okay, let me say I download on my desktop. Let's say, for example. Okay, save it. You can see there's an archive file, .zip file, right? So you're going to download it. And I'm now going to, I already launched my Eclipse. You can do that as well. So you can say File and then Import. And then under General, all right, under General, go to Existing Projects into Workspace. Next. And then make sure you select the archive file option there, right? It's really important, not the other one. I think a very common mistake is to select the first radio button. That's not the way to go. The second one, select archive file. And then you will say Browse. You just browse to wherever you store the file. So it's under my desktop, right? So right here, okay? Let's open it. And you should see some project name over here. It just indicates the week, right? Right now, September 12th. And then I would say Finish, all right? So that's what you will see. And when you import the stuff into your project, it doesn't compile, right? That's kind of expected because I haven't put in any implementation. So that's something I want to walk you through as well, since it's our first project to do together. So if you expand the this week's project, you can see under we got JUnits, right? It's already imported. You don't need to set up anything for your JUnits. If you expand the source folder here, you can see we got 2 packages. We got tests over here. So test utilities.java. So typically you'll be given just a single JUnit test file that's going to tell you exactly what you have to create and also implement to really get things work. And of course, we're going to go over this as well. I can show you what you should really look how you should look at them and also create the stuff accordingly. That's something I'll do in just one moment. And the model package over here is simply just empty, meaning that you got to put all the stuff you're supposed to develop for grading inside the model package for the actual test. You can see also one little hint over here. You can see one of the import here says model.utility. That tells you we're importing whatever you're developing from the model package. In this case, specifically, the utilities class. But you can see another hint about creating this class as well. All right? So that's a very simple structure here. Separation of concern. We got model, we got JUnit test. That's going to be the structure we're going to stick to, for the rest of the semester. So please just get used to it as early as you can. Okay, so I'll get back to this in just one moment. But why don't we make it this way, right? So you already got the project imported. So we got two problems over there, right? We're going to do one followed by another. So I can spend maybe a few minutes just to walk you through about what a problem is and also create some very simple skeleton file together with you. And then I'll pause the recording. I'll let you guys maybe try for maybe 5 minutes or 10 minutes to see how much you can program. Give you a little bit of pressure, right? To see if you can get things to work in 5 or 10 minutes. And then after that break that you can try, I can resume the recording and then I can go over a solution with you, right? We can do this for two problems. After that, we take another break and then we do the more paper exercise. Okay, let's see how that goes. Okay, this first problem, which you can also see in the instructions right here, right? You can see that's under the 2D array. So we are doing 1.1 right here. Okay, so that's a problem here. Okay, for that one there, let's go over. Okay, that's the first problem. So basically, we are given some input array. That's 2D array. Okay, given a 2D array, which you have to kind of declare. It will be something like this, right? 2D array. Okay, that will be the syntax. And I'll show to you in just one moment about declaring it. So we've got a 2D array of integers. Just make it simple. There could be string, could be character, or could be objects. But for now, it's simply just integer. Just as a look, like a heads up, when we get to the adjacency matrix implementation for graph, the elements in the 2D array is not going to be like a primitive type, like an integer anymore. It's going to be sometimes maybe nodes or maybe sometimes edge, depending on which one we are talking about. All right, so just want to let you know. So given the 2D array being the input, like a parameter, we want to find out or return a single row. And that particular single row has its elements sum up to be the maximum among all the other rows. Basically, go over every row in your matrix and find out the row that's going to give you the maximum sum. And of course, the integer here, since I say integer, right, you should really tell yourself right away, it does not necessarily have to be positive. It could be negative, it can be 0, it can be positive. So you shouldn't really just check to see what's really the row that has the maximum number of columns. That's not the way to go, right? You really got to sum up using some loop. So I think this exercise here is very nice for you to declare different variables at different scope and also use a nested loop to iterate through the array. So I think this will be a very nice exercise for you to try. So the value here could be negative, can be 0, can also be positive, all right? The only assumption we are making here, there are two assumptions here. Number one, the array is not empty, right? So there's at least one row. And that's something you may also want to ask yourself. If I know that the 2D array is not empty, how do I somehow encode this constraint maybe as part of my coding? How do I do that, right? So how to check, how to express in Java to say it is not empty. Right? That's something I want to leave as a question for you, but that's something you can go over when I go over the solution. And the second assumption is we don't really have more than one row that sum up to the same maximum sum. Right? There's exactly one row. So we don't need to worry about which one to return. Just one. Okay? There's only a single row we're going to return. And the single row that we're returning is just another 1D array. So that's kind of the interesting bit. So the input of the method is going to be a 2D array. However, the output will be a 1D array. All right, so that's something you will also see. Okay? So this is like a very informal description which you will usually be given as part of the comments. But to really see exactly how to declare the methods and also how to implement the body of the method, you have to know how to read JUnit test cases. Since you guys already took 2030 and also 2101, so I think a JUnit test should not be a big issue for you. So if you're still not confident, please brush up, at your spare time. But I can still go over with you. This is tutorial time. I can definitely spend more time with you on the basics. So in the starter code, starter projects, right? I just take a screenshot. So we are now dealing with this first test case right here, right? This one here. So this one just about the first method you got to define in the utilities, okay? So that one, let's try to read it together, right? Apparently we got two assertions, right? So first of all, let's highlight it right away. So we actually got assert array equals and also assert array equals. So this assertion here is actually very useful. So you can see rather than assert equals, it's really assert array equals. That means you can pass two arrays as the two arguments and compare them to see if they are equal to each other element-wise. So index 0, index 0, index 1, index 1, right? To see if they are pairwise equal to each other for the array equals. You can also maybe look up in the JUnit webpage about assert array equals to find more example. I think this one here should be pretty straightforward. And also some basics. When you actually can take two values over here, the first one here should be the expected value. And this one here should be the output from your method. You want to make sure these two will match. If they match, the assertion will pass. Otherwise, the assertion fail. Right? That's the basic. So the input here we have right here. Input number 1. Okay? And then it's going to return some output. And then we got something that's kind of expected, right? So expected should be passed over here. And also the output should be right here, right? And let's try to understand what's really here. There are two things you want to do, right? Number one, let's now try to see what's the method that's required to be declared. Why don't we do that right away? At least we try to get rid of compilation error as much as we can. And before that, since we are trying to handle one test at a time, why don't we comment out the second test just for now? Okay, I'm just going to comment this out. Right? All right, so let's handle test 1 first. Okay, we can definitely go back to test number 2 when we need to. And if you're worried about the shortcut will be Control / if you're using Windows. If you're using Mac, it's going to be Command / for block comments. All right. Okay, let's see this one here. At the moment, it doesn't compile. Let's see exactly what we should declare. You can see this syntax here in Java, right? You don't see any new keyword, right? So we are not creating any objects, as you can see. What does that mean? What kind of method are we declaring? Static method, right? So whenever you actually want to define something that's more like a utility type, just want to specify some functionality, it's a very standard practice to use a static method, right? So in the actual test, the method itself may be static, in which case you just say the class name .method. Or you may have to create some objects, in which case you're gonna call the method on the context object, right? So I'll give you both flavors, in a later tutorial. Okay, so this one here, utilities, is basically, okay, so this one here is a class that we have to create. So this is a class. And this one here, because it is called on some class name, so we know that it should be declared as static method. All right, and then you can see that particular method there takes input 1. And what's input 1? Input 1 tells you that it should be a 2D array, right? So you can see this one here tells you it is a 2-dimensional array. So when you actually declare this method here, its parameter should be 2D array. What about the output, right? The output, you can see when you make this method call over here, its return value is being stored back to output number 1. And what's that type? It's another array, but this is 1D array. So you can see this one here tells you that it is a one-dimensional array. So the parameter for the method that we're going to declare is a 2D array, but its return type is a 1D array, right? So that's kind of how we do the analysis. Okay, so far? All right. Having known this, why don't we try to declare something that's minimum just to get everything to compile, all right? So what I will do is I'm just going to, first of all, we know that we need to create a class called utilities. So new class utilities. All right, so once we make sure you save it. Right, so nicely you can see this one here has no red underline anymore, which is good, right? Because we got a class. And now we have to somehow create this method here, right? I would say to really avoid any typos, why don't we just copy that, right? So if you like, I can copy this whole line, right? So that will be a very good reminder for us. How about this? I will copy these 2 lines. You'll see why I'm doing that, right? Just copy that, right? And then I'll go back to utilities over here. And then I'm going to put things like that, right? So this is the method I want to declare. Let me just cut it, right? Put it here. So it should be a public method, so it can be used in another package. So I would say public. And then I know that it should be a static method, right? Public, static. And that one there should return something of type one-dimensional array. So I'm going to put it here, okay? And then the input number 1 is declared to be a 2D array. Okay? I should give it a name. Okay? If you recall in the problem description there, we simply said A right there. Right? But of course, you don't need to call it A. I'm calling A just right here, right? Just to be consistent. Okay? So what we do is we're going to put A here and then like that. Right? Of course, you want to get rid of these. All right, so that's the method declaration. Of course, we haven't returned anything yet. Oh, of course. Here, we'll want to get rid of this, right? We don't need it. You just return null. Because this integer array is a reference type, which just returns some default value. I would suggest in the programming components of your test, you really want to get the necessary methods actually declared first with the right parameter type and also return type, and return some default value just to make everything compile. So you wouldn't get any penalty by submitting something that doesn't compile. All right, that's all good. So now if we go back here, you will see that everything compiles, right? If you can also double check the project itself has no red cross anymore, like how you first imported it. All right, so we have done stage number 1. We get everything to compile for the test. Stage number 1. And stage number 2 is going to be more challenging. We have to somehow analyze the input and output to see how we should really implement it, right? So I'll give you a little bit of visualization and give you some hand-waving hints, and then I'll give you guys some time to maybe do it right away, give you a little bit of pressure, right, to see how much you can really complete, all right? So let's now take a look at this. And we are saying the following. The input is this. And the output is this. That's what we're saying, right? And I would suggest we try to visualize the 2D array. A 2D array from tutorial week number 1, where there's actually some guidance about what the basic syntax is. A 2D array is really an array of arrays. Josh.
What do we do if 2 things are the same size?
What do you mean, sorry?
Like if we happen, I mean, in this test case, there
Yeah.
isn't an example, but what are we supposed to do?
Yeah, I'm going to show to you. Yeah, so my point is, yes, the thing I just did is just to make sure everything will compile, right? We got a method that declared. So what we should do now is to really analyze the input and output, visualize it to see what's to be done. And you're also quite right. Here, we only got 2 examples over here. So that's why I got some exercise here. I can remind to you right away. I will highly recommend that you guys also try. right? Try to write more test cases. You know, you can just copy and paste each test and just try to write different input, different output, and also the assertion. I think the way I kind of set it up will be very easy for you to adapt. You don't really need to learn any additional JUnit syntax. Okay, let's now take a look at the logic, right? That's really the thought process, you know, for the programming component in your programming test. You want to, first of all, get compilation errors eliminated, and then you analyze or try to visualize what's the input and output. Let's take a look at the input. So the input is right here, right? It's an array of array. How do I see that? You can see this bracket here is an array. Each element there is itself an array, right? We got an array of 1, 2, and 3. 3 arrays, right? That's first of all how you should see it. Right? Let me say that again. This one here tells you overall is an array. Every element in there separated by comma tells you that every element at index 0, element at index 1, element at index 2, each one of them is a 1D array. Think about this is row at index 0. This is a row at index 1. This is a row at index 2. Right? I'll try to visualize it even more explicitly to show to you. But once you get more familiar, maybe just by looking at this, it will be enough for you to figure out the logic that's required. All right? So I'll make some notes for you right away. So think about this. So we got, this tells you, right? There's one here. And then we got index 0, index 1, index 2. So I might just say row 0, row 1, and row 2, right? So the ID there is just the row the index. All right, let's now visualize it. So it's really kind of a personal preference. I just personally prefer to really draw because we're going to talk about row and column. So because each one of them is more like a row. So I better just visualize this array here vertically, okay? Like what I said in the week 1 tutorial. So what I will do is, you can see that's input 1. So input 1 basically points to the starting part of an array right here. That array has 0, 1, and 2, right? 3 indices. So we got 0, 1, and 2. So 0, 1, and 2, right? And each one of them is a 1D array, 1 and this, right? So what we do is, for row 0, it's an array of size 4, okay? Okay, I'll try to draw as nicely as possible so it's very easy for you to see, 0, 1, 2, 3. And then the second one there, index 1, will just be 0, okay? And this one here will be 3. Okay, and then I'll fill it in. That'll be 0, 1, and 2. All right, like that. And let's fill out the contents. So the first one there, we got 10, 10, 10, 10. And this one here, that'll be 41. And this one here, minus 4, 29, and also 13. Okay, some syntax reminder, which is something you're supposed to actually already brush up, from last week. But I'll just mention that for your information. How do I refer to a particular row, for example? How do I refer to the last row? Right? The number of rows you have, can be calculated using the input 1 dot length. Agree? Okay. So if I want to go to the last row accordingly, guys, any thoughts? The last row itself is going to be a 1D array. How do I return just this reference that's going to point to the last row? Exactly what should I write? Anybody? Josh, I know you want to say.
I think you could just do input 1 and then only do first.
I agree. We should start with input 1. Let's start with that. Input 1 is a 2D array, right? But what should you pass inside?
You want the last one, so in this case 2.
I agree. Let's make it more general.
Okay.
Maybe it's not 2, right?
Input 1 dot
Minus 1. Aha, right? That's why I want to go over that, right? Gotta watch out. Otherwise, you gotta get into array index of outer bound exception, all right? Input 1 dot length minus 1. Right? Last row. Okay, you can work out exactly what first row and second row should be, etc. And what about, let's say I want to go to a particular cell. Let's say at row 1, and then colon 0. So here, when I say 1, I really meant the index, right? I don't really mean, I always start from 0 rather than starting from 1, right? Just, and this one here is also index over here. And this one here is supposed to be just a single element rather than a 1D array, right? That one there, I can just say input 1 still, and now go to row number 1. That one is going to make sure I go right here, row number 1. That's going to give me the entire 1D array. But that one there has only one single element, so you got to be careful. Sometimes you may have to also check how long each row is. You don't necessarily get a rectangle shape, like a second problem, or you might just get an irregular shape. And then once you go there, you can go for 0. So this part here is going to give you this one here. And then go to index 0 is going to give you 41. All right? So that one there is actually going to give you 41. All right? We don't really have to visualize this for every problem. I think it's only for the first one, just for you to see. Right? You definitely need this kind of visualization later once we get to the more advanced manipulation or the graph. Okay? Okay, all good. And let's now try to understand what's going on here, right? So based on this problem over here, right, we basically have to calculate the sum for every row, right? So somehow in your Java code, you're going to maintain possibly some sum. I'll say sum. Maybe a local variable, right? What would be the sum for the first row? 10, 10, 10, 10, 40, right? And the sum for the second row, which would be 41. And the third row over here would be minus 4, 25, 38. Right? So now, what's the row with the maximum sum? It should be this one here, not necessarily the longest one, right? It happened to be the shortest one. So what you should really return is exactly, not just 41 here, that's not what you're returning. You should return just this row over here, just that single array. So that's why you'll see the output 1 over here give you some array, and the expected value for that array should be just 41. You can see this 41 here is wrapped within the curly brackets that tells you it's a 1D array. All right? So you can think about this one here. This is also a 1D array. A row, which is a 1D array. All right. And of course, you can also take a look at the second test as well. And for the second test, I just give you another 2D array. And now the maximum sum will come from this particular row. In that case, that should be returned. All right? So now I'm just giving you one test case, but that actually got two scenarios for you to consider. But I got to make sure that will pass. All right, any questions? No? Alrighty. So you got everything you need. Why don't we say we let you take about, let's say 10 minutes. Okay, that should be no more than 10 minutes. And then program on your Eclipse and see if you can get a green bar. Okay, I'll pause the recording for now. All right, so just some issues I found some of your fellow students might run into. Because I kind of export the startup project from my computer, that one's using, at the moment, Java version 22. So if your current version is actually lower than 22, you might have some issues. It's possible. So should be easy to fix. What you should do is you can just right-click on your project here and go to Properties. and then go under Java build path, okay? And then go under libraries over here, okay? So I think for this path over here, you can see currently it's version 22. That may not be supported on your machine. In case it is not, you can just feel free to go to Edit, and then you can just change to maybe the default version that's under your system. And then say, okay, then that should resolve the issue, all right, just in case. But don't worry, in the test, it's not gonna happen, right? We'll make sure it's set up properly on the remote lab, right? Just the bottom one, yeah. Okay, if you got any issue, that's how you fix it, okay? All right, let's now go over the solution, okay? Yeah, just before I start typing the code, I just want to go over, just hand wave a little bit about the idea, okay? Let's say we have this 2D array right here, right? So that's the input. So the way to really figure out the row that has the maximum sum. So it's gonna be a linear scan of this outer array over here. We're gonna look at basically this row, calculate its sum, this row, calculate its sum, and this row, calculate its sum. And then we have to make sure we have some running maximum and then keep updating it, right? So because we assume that the array is, the 2D array is not empty, so we first of all calculate what's the sum for this particular row, and then make it a maximum just for now. And then every time we go to the next row, calculate what's its maximum, compare them. If this one happens to be bigger, that should be the updated running sum, running maximum, and then keep going. So as soon as we find out the maximum, we should also assign using the row index over here to assign a 1D array, etc. Once we go to the end, once we scan through all the rows, we should be able to figure out what's the one that with the maximum sum. Right? That's kind of the idea. Let's now type out a solution. Okay. Okay, so right here. So I'm gonna need some local variable. So integer, so row sum. So let's say just 0. Okay, that's just some default value. Okay, and I'm just gonna calculate the initial sum just for the first row. Okay, now let me just make it bigger. So calculate the initial sum for the first row and at index 0. Okay, let's do that. So we can say for, so we have to go to the first row, and then for the first row, we're going to go for each column, right? Each column, depending on what the length is. So I'm going to use a loop counter C just for column. Integer C, and the column will always be 0. For example, you can see here. So it's 0 over here and all the way to 3. How do I know its length? It's going to be input at index 0 dot length. That will give you the length for this array. All right. Okay, let's go back, and then we say C should be less than A0, which will give you the very first row, and then dot length. That tells you how many columns are there in that first row, and then C++, right? And then we got to calculate the sum. So you can say row sum plus equal, and then the current element. Because we're always in the first row, that 0 here will be a constant. And then the column will just be whatever C value is. All right, so here we just calculate the sum for the very first row and make it a running maximum just to begin with. So now we say integer maximum row sum will just be the row sum, whatever we calculated from this particular loop, just to begin with. Okay. And then we also have integer row index will be 0. So you can think about these two will actually work together. So as soon as we determine what should be the current maximum, current row with the maximum sum, we just assign its index. So when we return, ultimately, we can use that row index to return the 1D array. Okay. Okay, and then let's now go over the rest of the 2D array, in which case we'll need a nested loop, right? It's a very common way to really go over 2D. For each dimension, you just need a loop, so nested. So here we don't have to go for row at index 0 anymore, just start with index 1. So start the row at index 1. Since row sum already stores the sum from row at index 0. All right. So what we do is we're going to say for integer So I'm going to use the loop counter R standing for row. Rather than saying 0, we don't have to, right? Well, even if you put it there, it will just be a duplicate, like a waste of a resource, right? But I can just try to make it slightly more efficient. Asymptotically, it will be the same, really, right? So just say 1 here. And then R strictly less than a.length, right? You can see now we just go over row by row, right? From basically row by row, right? Starting from here, and then the rest, row by row. Okay, a.length, and then R++. And then for each one of them, we're just going to reset the row sum so we can calculate it. Row sum, just reset it to be 0. Okay? And then okay, let's do the column. Integer C, and then 0. And question, what should be the bound over here, the column? It depends on which row we are in, right? It will be somehow very similar to this. Before, we use 0 because we're only calculating the sum just for row at index 0 to begin with. But now here, we are making it more general. Now, which row should we get? Go ahead. Yeah, exactly, right? Okay, so that will be A at index R, right? Exactly, the length. Oh, sorry, the length. And then C++, right? So if you're not exactly sure, I would suggest spend some time, convince yourself. Right over here, we're using C less than, okay? You can see here we say C less than A0. And here we say C less than AR, right? You want to know why, okay? All right, and then we say row sum plus equal, that would be just the same, A and then RC, as opposed to A0C. And what we do is, once we calculate this row sum, we want to see if that can be the updated maximum sum. So we say if the current row has the sum that's strictly larger than the running maximum row sum. If that's the case, we should update. Otherwise, we can leave it the way it is. So maximum row sum will just be row sum. And also, we should update the index as well. Row index will be just R. Right? You can see the R here correspond to the current row that we are looking at. All right? All right? And then at the end, so after this double nested loop, the row index should be updated to the index of the row that has a maximum sum. Right? So at the end, we just return 8 at row index. All right? Maybe that's more or less what you have completed, okay? And let's double check. Okay, so here, if I try to rerun the test case right here. Okay, yeah, pass, right? But of course, I only gave you 2 example arrays. You should really try to really get more test cases done, right? Sometimes maybe in the test, I'll only give you some starter test cases. I might test some edge cases as well behind the scene. So you want to make sure your software is as robust as possible. All right, any question about this? Very good? Okay, so I think we got about 28 minutes. Why don't we do some big O exercise? Okay, so I think for programming, it's pretty good. So I will assign the second task, which is to determine. I'll leave the page over here clean for you as well. So the second task is slightly different. It's more like a returning either true or false, like a Boolean. So given the 2D array, you're going to determine whether the 2D array is a rectangle. So think about what a rectangle is.
Can you explain why the input's a rectangle and why it's not? Because I don't really get it based off the inputs.
Nope, you want to look at the test cases. Sometimes the description is really as good as you can really write. Because after all, just based on the natural language, sometimes it might be not as easy for you to visualize. So what you should really do is to look at this particular input and this particular input. So this one here is going to be true. It is a rectangle. But this one is not a rectangle. So that'll be some exercise for you. Visualize these two and see why the first one is rectangle, but the second one is not. That's something I want you to do. All right? Okay, yeah, well, that's important, right? Otherwise, I can tell you for sure, but I want you to try as well. Otherwise, if I give you some different problem in the test, then you wouldn't know how to do it.
I'm looking at the inputs. I don't understand why the top one is rectangle.
You will see. Once you visualize exactly how the array should look like, and think about what's really rectangle, right? So that's a hint you want to take. All right? Question?
Oh, no, I was just answering why.
I'll let your fellow student give a try, right? That's really the part you want to practice. All right, that's good. Okay, let's now do a little bit of maybe big O, okay? Okay. Why don't I do maybe for 10 or 15 minutes, we can take one more short break, and then we can complete the rest, okay? I think I may not be able to work through all the problems, but at least some, okay? So, in your, I think, let's do some very basic one, just to get all the necessary information covered, okay? So if you look at the problem sheets over here, so there are basically at least two types, excuse me, there are two types of problem that I'm including here, okay? So you can think about 2.1 and 2.2. So if I simply just give you some function, right? And then I just want you to decide whether what's the asymptotic upper bound, and then prove it, right? So that'll be more like a mathematical analysis. That should be very straightforward. I'm going to do one or two of them with you. Okay, you can do the rest. And 2.3 and 2.4 and 2.5. So these are the more interesting one. We want to make it more practical. Given some algorithm, of course, these are also some simple ones, but we're going to see one of them is actually going to be more challenging. You will need to identify some pattern. Okay, so this kind of exercise will be very important for later, because as we try to work out the asymptotic upper bound for algorithm, so this will be the kind of exercise you want to know how to do independently. If we talk about, for example, minimum spanning tree algorithm, if I give you the code, can you actually work out what the big O is? Right? So that's kind of the exercise we did in 2101. We're going to do it again in 3101. Just that the algorithm will be more complicated, right? Okay, let's now do some of them, okay? And then some of them we can either do next Friday, or we can do in the class on Tuesday. We'll see how the flow goes, okay? Or I can just assign to you. Okay, the first one. Oh, actually, let me just, right here, good. So you will see on the slides, there is a little formula or strategy you can actually use. So if you have, let's say, your running time of event is simply a polynomial, okay? So that means it's all input to the power of something, right? And this is something you can go over the slide, but I'll show you exactly how to adapt it. So if you actually got your running time like this, in that way, you can easily just choose the multiplicative constant and also the input size accordingly, okay? So multiplicative constant is just going to be the absolute value for each multiplicative constant over here, and then add them up together. And then the M0 is guaranteed to be 1. So this is assuming that every turn in your running time is simply polynomial. If you got log involved, sometimes it might work, but sometimes it may not work. So you really have to double check about the upper bound effects. If it works, that's great. If it doesn't work, you may have to increase the value for N0. So in one of the examples, you will see why I'm talking about this, right? And I'm leaving some little exercise for you, okay? Please try, okay? Maybe we didn't have to do it again in this course. It's a little proof to really show how this strategy can work in general. You will also see the solution on the slides, okay? And one more thing I want to maybe just remind you very quickly, right? So if you recall what we did in the class on Thursday, right? So given just a reference function and also given just a runtime function, you don't really see the upper bound effects. So you really have to choose the multiplicative constant C, right? We're going to choose the C. And once you have chosen the C, you're also going to see once we got this modified function over here, is only going to upper bound the runtime function here, starting from a certain point for N0, right? So these are the two things we had to work out, right, for each proof that we're going to do. All right, just to remember. All right, let's now do some simple ones. Okay, how about this one here, right? This one here, in some ways, very good because it already tells you this is the g of n, right? You can see this right here is the g of n, right? And this whole thing over here is the f of n. We're already giving you 2. So now we just want to somehow prove it. And to prove it, you will need to choose the c and also n0. All of them, at the moment, is simply polynomial. Right? You can see polynomial, you can the power 4, 3, 2, 1, and 0. Nicely sorted for you, or just nicely laid out. You don't have any log. So the answer should be very straightforward, but always good to verify. All right, so let's now try to look at that. To really prove this, first of all, to prove, we have to choose C and N0. But according to our strategy, we will know what to choose. So now we can say C will just be equal to, so we're going to select all the multiplicative constant. So we got 5 here, we got -3 here, we got 2 here, we got -4 here, and also we got 1 here, right? So these are we're going to take the absolute value for each one of them, okay? So it's going to be 5 plus -3 plus 2 plus -4 plus 1, which will be 8, 10, 15, right? Oh, I'm pretty sure it's right, 15, right? That's a C. And they're all polynomial, guarantee. N0 is going to be 1, right? Because of strategy. So N0 is going to be just 1. And so we choose these two, but now we have to verify just to be sure. All right? So we now want to verify. Okay? So since we have chosen N0 to be 1, we want to make sure the upper bound effects will really start from here. We want to be sure. All right? So we want to verify the upper bound effects. Starts at N0 equals 1. Okay? And the upper bound effects simply means somehow the F will be less than or equal to C times G. Of course, here I'm being a little bit imprecise. Of course, we got to pass the input value here. But of course, this input value will be 1. I want to sketch the upper bound effects for you. Okay? So now what should we verify? So we should verify the following. So runtime function and then pass 1, right? Corresponding to the 1 here. Should be less than or equal to, and the C we have chosen is 15. 15 times the G, which is M4, right? 1 to the power of 4, because N is now substituted by just 1. All right? Is it the case? Obviously, right? But let's see why. So this one here, f of 1, if you plug in, that being 1. So basically, well, want to plug in 1 into here, right? So you're going to get 5 minus 3 plus 2 minus 4 plus 1 without the absolute value, right? So that one is going to be 4. Okay, that's going to be just 1. Okay? So this one is 1. And then, how about this part here? That one here is 15, right? So 1 less than or equal to 15, true. So upper bound effect does start from there. As you can see, some insight. When we are doing this substitution here, we don't really take any absolute value for the running time here. But when we choose the C, we do take the running times. That's why it's guaranteed it's going to be an upper bound effect starting from 1. So when you do that little proof about that strategy there, that's exactly the insight you will see. All right? Okay, so this one here, check. Okay, so upper bound effects verified at n0 equals 1. All right, so these are, that's really what you got to do when you want to prove it, right? Choose the C, and also n0 should be 1 according to the strategy, but you also want to verify, especially when log is involved. Why don't we let you maybe do 1 or 2 exercises? Why don't we do that? Okay. How about we let you do, okay, how about just one of them? Okay, I think that's good enough. Can you look at example 3? Okay, I'll show you which one. Can you do this one here? All right, figure out what's the asymptotic upper bound for 3 log n plus 2. Derive it, and then prove it. So 2 parts, right? So if I tell you that f of n is 3 log n plus 2, and whenever I don't really tell you the base should be 2, right? Okay, give it a try, and then I'll pause the recording maybe for 5 minutes, okay? All right, let's now go over the third one. Okay, 3 log n plus 2. And whenever we want you to derive the asymptotic upper bound, it should be the tightest one. And that's something I also like to review in the lecture, just about what if you don't really have the tightest one. There will be some issue you want to watch out for. Okay, but that will be for the lecture next week. So the first one here will be the tightest asymptotic upper bounds. Should be obvious, right? Just choose the highest power. And this one here, you are only choosing between constants and also log n. And log n, I'll show you some diagram, it's on the slides. Log n definitely will grow faster than just constant. So that's why this will be the highest power intuitively, right? So I think there's a diagram there, I'll definitely just point out to you, but you can see on the slide as well. That's a diagram you want to be aware of about the rate of growth of the function. Right, so this will be big O of log n, right, for first one. So this will be the highest power, right? Just make a note. This will be higher power or faster growth than constant, which would be n to the power 0, right? It's the 2. All right, so think about this here is the g of n, the reference function. Okay, let's make a note right away. So you want to be aware of what g of n is. And then, so let's choose a c and n0. So I would say when you choose a c, just choose the way as if everything is polynomial. That's okay, but we may have to verify and fix, okay? So number 2, so we're going to choose c would be, so the multiplicative constant would be 3 and also 2, right? Well, if you want to make it even more closer to definition, 3 plus 2. Okay, so that will be 5. And then n0 will be 1. Careful, all right? So you can write it down just for now, but make sure you verify on the side as well. It could be that because we got log involved, in which case the strategy may not work sometimes, okay? In that case, we're going to verify, okay? So let me put a little question mark over here. Okay, so now we have to verify. Okay, I'll put it aside here. So the way to verify is right here, okay? Okay, so we want to verify. So we want to make sure the upper bound effects is going to happen at n0 equals 1. So that means we want to verify f of 1 should be less than or equal to c times g of 1. Conceptually, that's what we want to do, right? And let's now do the replacement, substitution. F of 1 right here is going to be 3 times log 1 plus 2. And then less than or equal to, the c we have chosen is 5 times, what's g? Just log n, right? Okay, good. And then we got right here, log n, yes. Okay, let's now simplify, right? So log 1, 0. Agree? Okay. That's something I don't need to remind you, but just make sure you understand why. Okay. So this one here is going to be 3 times 0 plus 2, less than or equal to 5 times 0. Basically boil it down into 2 less than or equal to 0. Is that true? No. Right? So upper bound, in fact, doesn't really happen from n0 equals 1, which is kind of expected some cases because whenever you got log involved, you always got to double check for that strategy. Okay? So this one here, no. Upper bound effects. So what you should do is try a larger value for n0. All right? So I'm going to write it down here. So now rather than 1, we're going to put 2. And then verify. And this will be some exercise for you to see if that works. If 2 doesn't work, go for 3. And with some small increments, you should be able to find it. You shouldn't take too long to find it. Okay, I think for this kind of exercise, that'll be enough. All right, any questions? All right, so I think there will be exercises that we're going to focus more on, just about how, given some algorithm, some code, how can we figure out the running time and also to prove it, right? Maybe mainly to derive the running time. So we'll do maybe 1 or 2 examples in the lecture, and some of them I can assign as an exercise for you. And then we'll do other stuff in the lecture, all right? Thank you so much. And then if you got any short question for me, I can stay for a few minutes if you want to. Okay, thank you.